could solve by factoring. I also told you if you had chose to use quadratic formula, because I didn't say solve by factoring, you could have done it. It's way longer, but optional. Okay, so we have to get it equal to 0. So we're going to go 2x squared minus 3x minus 2 equals 0. What times what equals negative 4. What plus what equals negative 3. Negative 4 and 1. And we have to decomp because we have a number in front of our x squared that isn't 1. So we're going to get 2x squared minus 4x plus 1x minus 2. If you flip-flop those, it doesn't matter. You're still going to get the same factors. Take a 2x out, we're left with x minus 2. Take out a plus 1, we're left with x minus 2. And if you would flip-flop the 4x and the 1x, you'll just have the factors in the opposite order, but you'll still have the same two factors, right? So you're going to get 2x plus 1, x minus 2 equals 0. Then we have to solve them separately. So we get 2x plus 1 equals 0, x minus 2 equals 0, 2x equals negative 1, and we divide by 2, x equals negative a half, add 2, x equals 2. So if I ask you to solve, your answers are negative a half, 2, box, x equals. That's what solve means, right? But I could ask you to find that x-intercepts the roots of the zeros. I did find them already, didn't I? So if I ask for x-intercepts roots or zeros, you would just list it with a 0. So you'd go negative a half and 0 and 2 and 0. So if I asked for x-intercepts, it would just change it to be like that, as opposed to solving, which is just x equals. If I go into my calculator, I could do second trace 0, left bound, right bound, enter, and I get negative 0.5, and then second trace number 2, left bound, right bound, and I would get 2. I can check these every single time and know I'm right, be happy, or know I'm sad, and go back. They're wrong. Okay? Number 2, however, nothing multiplies to give me negative 21 and adds to give me negative 2. Yeah. It's encroaching you? Go into his business. Do that. I feel like that's got it. Oh. Aha. Life changing. All right. So nothing multiplies to give me negative 21 and adds to give me negative 2, but I is equal to 0, so I know I can start with it. If I can't factor it, my only option is the quadratic formula. This is a equals 3, b equals negative 2, c equals negative 7. And I fill into my formula. X equals negative b. So negative and negative 2, right? Which actually makes it positive 2. Plus or minus the square root of negative 2 in brackets squared minus 4 times a, which is 3, times c, which is negative 7, all over 2 times 3. X equals 2 plus or minus, what does that equal? 80? 88? It's a whole bunch of 88s. Is it 80 or 88? 88. Over 6. Now 88, what can I reduce it to? Off to the side. You divide it by 4, right? 4 and 22. 4 comes out, it's a 2, so I get 2 root 22. Can I reduce 22 anymore? No. So now I can write x equals 2 plus 2 or minus 2 root 22 over 6. And then am I done if I say exact values? No, I have to check for the 3 for 1 special, right? So I go, can I take something out of all 3 of those? It has to come out of all 3 or it can't come out at all, correct? And I can take out a 2. Now this 2 turns into a 1. This 2 turns into a 1. And this 6 turns into a 3. So you actually get x equals, now the 1 in front of the square root of 22, 1 times root 22 is still root 22, correct? So do I have to write the 1 that's in front of the root 22? No. Do I have to write the 1 that's in the front though? Yes, because it's 1 plus or minus root 22. If you don't write it, it's just plus or minus root 22, which is a totally different answer. So we have to go 1 plus or minus square root of 22. If you wrote the 1 in front, you're not wrong. all over 3. And then that splits into x equals 1 plus root 22 over 3, and x equals 1 minus root 22 all over 3. Can I check it with my calculator? Yeah, I can put 3x squared minus 2x minus 7 into my y equals. I can find my x-intercepts in decimal form, correct? Then I can type in 1 plus root 22, enter, divided by 3, 1 minus root 22, enter, divided by 3, and it should match the decimals, shouldn't it? But because I said exact values to you guys, could you turn it to a decimal? Should you turn it to a decimal if it says exact values? No. Exact values means not a decimal. That's exact values. Okay? Don't turn it to a decimal if I ask for exact values. Number 3, this is from last unit. It says determine the equation of a quadratic with a vertex, negative 2, 4. So I'm going to label that PQ because my vertex is P and Q. Passing through the point 1 and negative 3. Every coordinate is an x and a y. And what form do I always have to fill it in to get a quadratic equation? Vertex form. So it's y equals a x minus p squared plus q. Y is negative 3 equals a x is 1 minus p, which is negative 2. What happens when I get a minus minus? Really big. Plus squared plus 4. What happens if I swap the point and the vertex? Doesn't matter, does it? Is that true? If I swap the vertex for the point and the point for the vertex, so I put the p and the q under the point and the x and the y under the vertex, does it change it? Yes, it totally does. So you can't swap them. The p, the q has to be under the vertex. The x, the y has to be under the point. If you swap them, you're going to have the wrong answer and it'll be there for you, waiting in your wings, but it's going to be wrong. So we don't want that one. So we subtract our 4 over. We get negative 7 equals a, and then this is 3 cubed, which is 9. Then we divide by 9. Yep, they're multiplied, so how do I get rid of the multiplication? Yeah. And then I'm not done because that's not an equation, that's just the a. So I do the equation with the x and the y staying x and y, and I fill in my a and my p and q. So I get a is negative 7 over 9, x minus 2, so plus 2 squared plus 4. Then I'm going to get you to flip to your notes. We're on page, I don't know. -2. I'm just going to pause. Page 24. So before we even talk about discriminant, put your pencils down, put everything down, you're just going to pay attention. We're going to get to 24, page 24 in a second here. But before we get to page 24, I'm just going to give you a blank screen, you're just going to pay attention. No writing, no nothing. Just using your big brains, paying attention. Yeah? So the quadratic formula that we dealt with yesterday, we could have x equals, let's say 6, plus or minus something over 2. Let's keep the 6 and the 2 the same. Okay? If the something under the square root was like 22, how many answers would I get? How many x-intercepts would I get? I get 2, correct? I would get x equals 6 plus root 22 divided by 2, and I would get x equals 6 minus root 22 divided by 2. So I would actually have 2 x-intercepts, wouldn't I? We agree with that statement? Okay. What happens if I keep the 6 and the 2? So I would get, in my end quadratic formula, when I was done it, I would have 6 plus or minus root 0 over 2. So now what's under the square root sign is a 22, right? Now I'm putting a 0 under it. Say I solved it out and I got a 0. What's the square root of 0? 1. No, square root of 0 is 0. So I would get x equals 6 plus or minus 0 over 2 if what's under my square root sign is a 0. We agree? What does adding and subtracting a 0 do? Absolutely nothing. So my answer would be 6 over 2, which is 3. So how many x-intercepts do I get when what's underneath that square root is a 0? I get 1, because I add a 0, I subtract a 0, it does nothing. I get 1 answer. We agree? So when I had my square root, you're not going to write this, you're just paying attention. When what was under here was greater than 0, so positive, like 22, 5, 7, 9, 8, 6, 4, 25, 100 million, it doesn't matter. When what's underneath this square root is greater than 0, I'm going to get 2, correct? So when what's underneath here is greater than 0, I'm going to get 2 x-intercepts. You're not writing this, we're just feeling it out. Then, what's under my square root is a 0. I'm going to add and subtract a 0. I'm going to get 1 x-intercept. Because adding and subtracting a 0 doesn't change anything, correct? What happens, though? So I've dealt with when that's 0. I've dealt with when it's greater than 0. What have I not dealt with so far? When it's less than 0. So say I give you the 6 and the 2, just like before. But now I go plus or minus the square root of negative 16. Type in your calculator, root negative 16, square root of negative 16. Not any of the rest, just the square root of negative 16. What does your calculator do? It gets mad. It says what? Non-real error. It says error. It says nope, not happening. It says not today. That's what it says. Okay? In its lingo. Why? Can I take the square root of a negative number? Is that allowed? No. Can I take the cube root of a negative number? Yep. Because the cube root is when you have 3 of the same thing, you can take it out. The square root, you have to have 2 of the same thing. You can't take the square root of a negative number. So what happens when your actual value underneath is less than 0 is you get no x-intercepts. So what does that mean? That means the graph is either completely above the x-axis or the graph is completely below. We agree? No x-intercepts happen when you get that negative under the square root. You can't get anything. Your calculator looks, it fights you. It's like, I'm not giving you an answer. Not today, not tomorrow. Ain't happening. This one, when I have 1 x-intercept, I actually get tangency. So I get it touching the x-axis in one spot. It just, the vertex is actually on the x-axis is essentially what happens. Or it would be this way. So when your vertex is your x-intercept, that's when you get the square root of 0. Because you're going to get 1 x-intercept. So when your vertex is your x-intercept, that's when that happens. And then when you have 2, it could look like this. Or if it's concave down, it looks like this. You literally just get 2 answers, which is kind of what we've dealt with so far, right? We've always gotten 2 answers. So what's underneath that square root function is what matters. That's to tell me if I have 1, 2, or no x-intercepts, correct? What's underneath the square root sign. Did the 6 and the 2 change at all? No, I kept 6, 2 here. I kept 6 and 2 here. I kept 6 and 2 here. What was based on whether I have 2, 1, or no x-intercepts was what was underneath that square root sign, correct? What's underneath the square root sign? You're not writing this. We're going to get to it in a second. What's underneath that square root sign is actually b squared minus 4ac, correct? This is what's underneath the square root. When b squared minus 4ac, I don't care what the square root symbol, I could give a crap about that. But when b squared minus 4ac is greater than 0, what happens? When this under here is greater than 0, what happens? How many x-intercepts do I get? 2 x-intercepts. When what's underneath here, that b squared minus 4ac equals 0, what do I get? 1 x-intercept. And then what happens when b squared minus 4ac is less than 0? How many x-intercepts did we get? None. It fought us. It was negative, right? Now what you're going to learn right now, when we go back to the notes, is b squared minus 4ac is actually called the discriminant. And if I ask you for the discriminant, I'm literally just asking for b squared minus 4ac, tell me what the answer is. So if I ask you for the actual x-intercepts, what are the x-intercepts, correct? You have to find them. You would have to put it into the quadratic formula. You'd have to get me 2 answers or 1 answer. It would be an answer, correct? If I asked you for the x-intercepts, you have to do the whole quadratic formula, give me an answer. We agree? But if I ask you for the number of x-intercepts, if I ask you for just what are the number of x-intercepts, I just have to use the discriminant. If the discriminant is greater than 0, I have 2. If the discriminant is equal to 0, I have 1. If the discriminant is negative, I have none. I don't actually have to find out what they are if I just ask you for the number of x-intercepts. So we're going to go back to page 24. Now you can pick up your pencils. We're here. So the discriminant, I'm going to make this smaller. So the discriminant, the radicand of the quadratic formula. So it's what's underneath the radical. That's what a radicand is. It's just the number that's under the radical. You learned that last year. Is called the discriminant because it discriminates among the 3 possible cases of quadratic functions and their corresponding zeros that occur. The number of solutions are sometimes referred to as the nature of roots. We're not going to deal with nature of roots at this very point. We're going to just look at the discriminant and determine the number of roots, the number of x-intercepts, the number of zeros. Okay? Without having to use the whole quadratic formula. So what do I need you to do? I need you to type this into your calculator. Go type that into your Y1. And then you're going to do a quick old sketch. And you're going to give the zero approximation. So you're going to have to find the x-intercepts using your calculator. Make sure you're using your calculator to find your x-intercepts because that's an outcome as well. So we keep practicing it as well. If I want to do an accurate sketch, good things to have would be, I'll show you how I would do the first accurate sketch for myself. I know this is my what? What's that? My y-intercept because it's in standard form, correct? So 1, 2, 3, 4, 5. I know my y-intercept is at 0, 5. I want to find my vertex. Well, it's a minimum, so I'm going to find the minimum. Second, trace, minimum, number 3. Left bound, right bound, enter. And I get 3 and negative 4. So I have a vertex at 3 and negative 4. How do I get my x-intercepts? Second, trace, zeros, which is number 2. Then go on the left-hand side of it, right-hand side of it. And I get 1, 0 as my first one. And then second, trace 2. We have to do it again. Next one I'll show you on the board. Left bound, right bound. And I get 5, 0. I get 5 and e to the negative whatever, but I don't really care. So this is my graph. Very broad sketch. Make sure you have arrows at the end because it keeps going. Try and make this be your vertex. I didn't do a very good job. How many times does it cross the x-axis? 2, right? 1, 2. So it crosses twice. Crosses the x-axis twice. So the discriminant, which is really what's underneath the square root function, what am I expecting it to be in this case? Yeah, because this crosses twice, I'm expecting b squared minus 4ac to be greater than 0. Correct? How do I find out? Well, this is my a. So if I go y equals 1x squared minus 6x plus 5, what's in front of my x squared is my a. What's in front of my x is my b. What's at the back is my c. I don't have to do the entire quadratic formula because I'm just telling you that I have 2. So I plug it in. Go b squared, which is negative 6 squared minus 4 times 1 times 5. This becomes 36 minus 20, which is 16. What is 16? Greater than 0. So if my discriminant is greater than 0, what happens? I get 2x intercepts. How am I going to get 2x intercepts? Because I'm going to take the square root of 16. Square root of 16 is 4. I'm going to add 4. I'm going to subtract 4. I'm going to get 2 different answers. When your discriminant is greater than 0, you get 2 different answers because you're going to add it and you're going to subtract it. You guys are going to sketch the second one. Sketch it. Tell me how many times it crosses and get the discriminant. So if we look back at the previous one, if I literally just ask you for the discriminant on a test, your answer for this one would be 16. That is the answer to the discriminant. It is 16. You fill it into b squared minus 4ac and give me an answer. So discriminant is 16. We agree? Now what we're going to talk about as well is nature of roots, and I'm going to write it in here. When it crosses twice, if I ask you for the nature of the roots, you're going to say 2 real and distinct. Real means it exists, distinct means they're different. So if I give you this exact question, y equals x squared minus 6x plus 5, and I ask for the discriminant, your answer would be 16. If I ask you for the nature of the roots, you're going to tell me 2 real and distinct. Because there's 2 and they're real and they're distinct. They're different. Difference in what I could ask you for. If I ask you for discriminant, your answer is 16. If I ask you for nature of roots, you say 2 real and distinct. When I look at the second one, I have x squared minus 6x plus 4. It's a minimum at (3 and -5). How did I find that? I typed it in my calculator. Nothing crazy. Then I want the x-intercept. Well, the y-intercept's at what? What's the y-intercept at? It's in standard form, so it's the back number, right? Because when I fill 0 in for x's, these will cancel. So I know I have a y-intercept at 4. Then I have to get my x-intercept. Second trace, number 2. And if you're still struggling with using your calculator, you need to come in and ask questions. So this one's at 0.76 and 0. So I'm going to label it at 0.76 and 0. And then I'm going to go second trace number 2. And 5.23. And 5.24 and 0. Because it says -1 e to the -12. And whenever it says e to the negative anything on my calculator, that's just 0, right? And then it's okay. How many x-intercepts do I have? 2 x-intercepts. So what am I expecting my discriminant to be? Greater than 0. And if I ask you for the discriminant, I just literally fill it into b squared minus 4ac and give you the answer. That's all the discriminant is. Should be a really easy question on a test. If I ask you for the discriminant, you fill it into b squared minus 4ac, you give me an answer, you move on. You don't even tell me anything about it. Just give me the answer. So let's find it out. So we have y equals 1x squared minus 6x plus 4. So this is my a, this is my b, this is my c. So I'm going to get negative 6 squared minus 4 times 1 times 4. And so I get 36 minus 16. So it equals 20. So that is the discriminant. If I ask you for the discriminant, you should give me an answer, like 20. Or in the previous one, 16, right? The discriminant is 20. Now if I ask you for the nature of the roots are just the zeros, or the x-intercepts. When it's greater than 0, my nature of my roots will be 2 real and distinct again. Because they're 2 real and different roots. 2 real and distinct. Real means they're a number that is in the real number system. Distinct means they're 2 different ones that are different. Like there are 2 answers that would not be the same, right? Try this one. Yep. If I go to graph this one, my vertex is actually where? It's on the x-axis. When the vertex is on the x-axis, it only crosses once, which actually means I still have 2 x-intercepts. They're just exactly the same. So I have 2 real and equal. And I'll show you why. If I go to factor this, I'm going to get x minus 3, right? When I solve each of these, I'd get x minus 3 equals 0. X minus 3 equals 0. So I'd get x equals 3 and x equals 3. So how many actual x-intercepts are there? 2. They just happen to be the exact same, which is another word for saying equal. So we have an x-intercept or a y-intercept at 9. And then it bounces here, so it does something like a sketchiest sketch, but pretend it's a really nice one. So I just want you to sketch, right? Not accurate, nothing, just a few things in there. So I know I have 2 x-intercepts that are the same. And that happens when my vertex is on the x-axis, right? When my vertex is on the x-axis, I have 2 x-intercepts that are the same. So if I want to find my discriminant, A is 1, B is negative 6, C is 9. I'm expecting my b squared minus 4ac to equal 0 this time, because in order to get the same x-intercept twice with the quadratic formula, you have to take square root of 0. When you add a 0 and you subtract a 0, you literally just get the same answer twice. So I'm going to fill it into the thing. My discriminant, I'm going to get negative 6 squared minus 4 times 1 times 9, which is 36 minus 36, which is 0. And that answer 0 is the what? The discriminant. And now for the nature of the roots. For the last 2, we said 2 real because they're real answers and distinct because they're different, right? Ours now is going to be 2 real because they're real. And what are they this time, though? They're the same, which is another word for equal. They're 2 real, they exist, and they're equal, they're the exact same. Then we're going to flip over. What do you suppose is going to happen on this one if you were a betting person? It's not going to be on the x-axis at all. It's probably going to have a discriminant that's negative. It's probably going to have no crossings, right? Because, well, there's the last one, and now the rest did the other stuff. So you'd be right. All right. So we're going to look at this one. I know that it has a y-intercept of 13, and then I want to try and find the x-intercept. When I press graph, shockingly, Carson's right. It doesn't cross, because he's a genius, and he realized there's a last case that has to still come up here. So I'm going to find the minimum, second trace minimum. Left bound. Right bound, enter. And it's at 3 and 4. So it does not cross the x-axis, which means there can't be any x-intercepts. And in order for it to not have any x-intercepts, what has to be under that square root function?
Negative.
A negative, so a less than 0, right? Because they can't take the square root of a negative. Now, this is my A, this is my B, this is my C. So I get B squared, which is negative 6 squared, minus 4 times 1 times 13. So I get 36 minus 52. Negative 16. What happens when I get a negative under the square root? Can I keep going? If I go square root of negative 16, my calculator is going to be like, not happening today, Lloyd. Stop. So you wouldn't actually be able to finish the quadratic formula. You'd have to just stop. It would be done. What is this number called? The discriminant. So we had two real and distinct, meaning two real that existed, and they were distinct, meaning different. Then we had two real, and they were equal, which meant they were two. There's two of them, but they happen to be the exact same. So that was when I had the vertex on the x-axis. And then the nature of roots for this one is actually non-real roots. They're not real. They don't exist. They're not there. They're actually imaginary. We're going to do a little summary. Yeah. So what case, example, does it contact the x-axis twice, touch it once, or not at all, occurs when b squared minus 4ac is greater than 0. What happens when it's greater than 0? It touches twice. What would the nature of my roots be? Two real and distinct. Two real and different. Which is another word for different. Distinct. When are the roots rational? Rational means not decimals. Or irrational meaning decimals that don't repeat, don't terminate, not fractions. Anyone know? When what's under the square root symbol is a perfect square. So like an example I'll show you. So what's under the square root, the discriminant is like 16. Then I'm going to get plus or minus 4, right? Or if what's under my square root is 36, then I'm going to add or minus 6, right? Or if it's like plus or minus 144, I'm going to add or minus 12, correct? So that's when you're going to get a rational root, one that's not a crazy decimal answer, is when they're perfect squares. Like square root of 16, square root of 36, square root of 49, square root of 144. When are you going to get irrationals? When they're not. So an example would be when your discriminant is like 14, because the square root of 14 is a decimal, right? Or plus or minus the square root of 50. That's a decimal. It's not a perfect square. For b, when b squared minus 4ac equals 0, how many times does it touch the x-axis? Technically twice, but in the exact same spot, right? So it looks like once. We'll say technically twice. Exact same spot. And when does this occur? When what's on the x-axis? What has to be on the x-axis in order for this to happen? A vertex. Because then it just hits it and bounces down, or it hits it and bounces up, right? You can't cross through twice. What are the nature of the roots when you get the exact same answer twice? They're two real again, because there's two of them. They're real, and they're what, though? Equal. What about b squared minus 4ac is less than 0? What happens there? How many times does it cross? It doesn't cross. It doesn't touch the x-axis. Which means I have no roots, right? So the roots that exist are non-real roots. We're going to stop here and do some partial homework. I'm going to do the last little bit tomorrow because I just covered everything in one, so I can give you a little bit more time to work on it. Now, just so you know, your homework from now on is going to be submitted online because it's hard for me to keep track of people who have submitted it and then people who haven't submitted it, and then they hand their form in and it's in the wrong spot, and then people are having to rip it out of their books, and that would drive me insane if I had to rip my stuff out of my books. Some people are handing in books, some people rip stuff out of books. It's driving me crazy. So what I want you to do by tomorrow is go to your assignment and use your phone and just take pictures. Go snip, 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 snip. Take them all at once and then just post them. Now what you can do is you can download, I think, Adobe. I think some of the iPhones, they just have a scanner with them. Just make sure you scan it as one document so I can just like slide through it. If you do it as a separate picture each time, I have to like open the picture, look at it, close it, open the next picture, look at it, and I'm like, I'm really not happy with you at that point. Third picture, fourth picture, 17th picture, closing it, 18th. I'm just like, oh, I thought you were a nice person, but not now, not anymore. You're not very nice. As I'm opening the 20th document, okay? So I know iPhones usually just scan into one. If you're someone who does it wrong, you take a whole bunch of pictures and I'm judging you by the 19th picture, I'll talk to you and be like, hey, let's try and figure out how to get it into one, okay? So submit it how you think you're supposed to submit it, and then I'll report back to you as to if it was conducive to helping me or if it was conducive to causing me to cry. One or the other. And then we'll go from there. So if I don't talk to you, you did good. You just hand your stuff in, you done well. And then if I talk to you and I'm like, just so you know, then we'll discuss how to figure out how to put it in one document instead of a whole bunch. Okay? So you just try it however you know. It's in the same thing, it's just not material this week. It actually is an assignment. So when you go to homework from October, I think 4th to whatever, 14th or something, 7th to 14th, I don't remember what it was, 4th to 14th. It's just an assignment. So you'll click into it now, and you'll post your stuff there. Okay? And then I just check it in there and give you a mark that way. And then you get to keep your stuff, and I get to have your stuff. And then if you don't hand it in on time, you can still hand it in later, and I can look at it then. Instead of like trying to keep track of who's handing it in and who's not, it's painful. Can't do it. Okay? Your homework for today is down here, but it's not that.
Damn.
Yeah, I just podcasted that. Good job, Shmaleb. I wouldn't want to say your real name. Shmaleb. Okay, the first one is to just find the discriminant. So what am I filling it into? Equation into b squared minus 4ac, give an answer, correct? Do I want the whole quadratic formula done? No. I want the answer to the discriminant. Okay, that's number one. Number two says, without graphing, determine the number of zeros. How can I determine the number of zeros without graphing? Discriminant. I'm going to go and I'm going to fill into the discriminant. And if b squared minus 4ac is greater than 0, I have 2 real and distinct. If b squared minus 4ac equals 0, I have 2 real and equal. Namely, technically, kind of just like 1. And then if b squared minus 4ac is less than 0, I have no real roots. Does not cross the x-axis, right? So if I ask you how many times it crosses, you don't go to your calculator, you literally just plug it into here, and if it's greater, you get 2, if it's 1, and if it's none, right? You did this already, so we're going to ignore that. It's just making you use the full quadratic formula, which you just did a whole lesson on.
3, 4, 5, 8, 9,
You're ruining my mojo, right? Shmela. You did 3 yesterday, right? 4 and 5. Meh. I don't care. And then these will be done at a later date. Just not right now. 1 AC, 2 ACE. 1 ACE, 2 ACE. Does that look like a whole lot of work? Like you should be
Yeah.
not making it through tonight?
Yeah.
I believe in you. 6 questions. One of them is discriminant. One of them is to find a discriminant and tell me if there's 2, 1, or none. Okay? 6 questions. I believe in you. Even you.